Today I'm going to talk about WebSocket and Java, and if you were expecting a kaleidoscopic talk about HTML5, this isn't it. It's mostly focused on WebSocket. So I'm Danny Coward. I've been at Oracle since they bought Sun, and then I was at Sun before that for a while. And here's the... this is because I might talk about some future plans, so don't sue me if I get the date wrong by a few days. So what I'll cover, I wasn't sure how familiar people would be about WebSockets, so I thought I'd just kind of get us all on the same page about WebSocket, the protocol. And then I'll talk about the JSR fairly briefly, and then mostly I'll focus on showing you the API with some sample code, and I think I have a demo that's going to work. So the roots of WebSocket came from, I suppose in the early 2000s when websites became more and more interactive. There was more and more need for the web pages to be, animated in some way in terms of information, which required the server to push out notifications, things like stock quotes or people writing the first chat clients and things were becoming popular. So HTTP, being the primary protocol, doesn't really support this very well at all. It's a request-response interaction model. So if the server wanted to push, it depended on the client doing some extra smart things. Things like, polling at some regular interval or keeping the HTTP connection alive and waiting for snippets of updates to come down, whether or not there was any need for that connection to be open. And then some programming models like Comet and Ajax and a sort of family of little programming models were built on these ideas to try and bring this interactivity to websites, which was great, but it meant that there were a lot of open connections on the internet that weren't needed all the time. The server didn't always have something interesting to say to these websites, so it was inefficient. So that was the roots of WebSockets, and the idea is to have a new TCP-based protocol that is conversational. It's symmetrical from the client to the server once the connection is established. It's full duplex, meaning that messages can be sent simultaneously from one end to the other. You don't have to wait for the other person to speak before you speak, so all the messages can interrupt each other. It took several revisions, and it's been a winding path, but it's now a standard, the IETF, for the protocol. And there's a JavaScript API that's defined in the W3C that's tracked this draft, this network standard. So things are looking in pretty good shape after it not being quite clear how widely adopted WebSockets would be. And you can Google this kind of thing yourself, but I did take a look at what the current state of browser support for WebSockets is, because still the primary model is a browser client talking to a web application. So I don't know how clear it is here, but I'll give you the highlights. No, I don't have a laser pointer. If you see 3 from the end, there's a current line, and anything green or greenish means that WebSockets is supported. So I'll read off the most popular ones. IE is experimenting with support, doesn't support it yet, but plans to in IE 10. So that's going to be the next version. Firefox does, Chrome does, Safari does, Opera does partially. It doesn't support all the features. iOS, Safari on iOS does. So even just scrolling through those browsers, we've sort of covered hundreds of millions, if not billions, of web pages on different devices. Okay. Does anyone have a cat that they brought? Wait. I think I might be the cat. There it is. Okay. Current, this is the line. So it's nearly all green is basically it. IE is the big popular holdout. It's supported on BlackBerry. It's on Chrome for Android. So tablets, smartphones, desktop, laptops. It's either here today or it's going to be here very soon. And when I say support, that generally means they support the JavaScript API and the web protocol underneath. So, don't be scared to start really looking at it seriously if you're not already. So the basic idea, just as a primer on WebSockets, if you're not familiar with the protocol, there are 3 stages. First, there's a handshake process to establish a connection, and I'll talk a little bit about that. Then there's this stage of, once the connection's established, messages of various shapes and sizes flowing backwards and forwards between the 2 peers in the conversation. And then finally, there's a part of the protocol is about ending, how to end gracefully or otherwise the connection. So to establish a connection, the client creates a handshake request. This is a specially formatted HTTP request. So one of the ideas of the protocol was that it layered well on top of existing technologies. And then the server thinks about it for a moment and formulates an HTTP response in a special format to say, I accept your connection request. And then once that's done, well, we'll get there. This is what the HTTP handshake request looks like. It's a GET to a URL. It uses the HTTP upgrade mechanism. It's the first use outside of SSL to do that. It sends a little dongle so that the client can, when the response comes, the server knows to allow the client to check that the response came from where it thought it came from. And then there's a few other details, like in establishing the connection, the client can request that certain subprotocols and extensions of the WebSocket network protocol be supported on that connection. So if you have a subprotocol of WebSockets that's about chat and it's just dedicated to doing really good chat applications, in the handshake request the client will indicate that. Then the server examines this information and it looks at things like, the URL. Does it match an endpoint that it has to serve for that URL? It will check that it's well formed and so on. It will check whether it supports any of the requested subprotocols or extensions. And then it makes this response if all goes well. And then once the response is made, the client knows that everything's good. The TCP connection is established between the 2 physical machines. And then you're kind of up and running. And once you're connected, the protocol defines a number of events that defines the life cycle of the connection at the application layer. So the first thing is that both parties get notified that the connection is now open. Then any number of messages can be sent, maybe in this case from the client to the server. The client can send one to the server. We'll get to all this in much more detail. There's a WebSocket event that indicates there's been an error on the connection. Either the physical connection may have gone down or there's a problem with the format of the message, for example. More messages can flow. And then finally, one of the parties can initiate the closing of the connection and the other party is notified that the connection has gone down. And then when all that's happened, at the end of the conversation, you disconnect the 2 machines. The TCP connection is brought down. So that's a quick flyby of WebSockets, how it works. Alongside development of the standard, there were lots of Java APIs that started being developed to allow Java developers to use this protocol. Largely, it has to be said on the server side because, like I say, the primary deployment scenario is still a browser to a web server. And here are just a few of the examples. I suppose the notable thing is that the leading Java web containers like Tomcat, like Coucho, like Jetty and the JBoss and so on. Sorry, JBoss is Tomcat. But they have been bringing these APIs into their web servers, I suppose due to developers wanting to use them. And then at Oracle, we've supported it in Grizzly for some time, kind of a lower level API approach. And then more recently, where this project grew out of, we experimented with some annotations in the WebSocket SDK project that ultimately sort of led to this JSR in a way from our perspective. So we started the expert group in March, I think it was, to start working on this. That's the number. Obviously, you can Google all of this. The specification is being run in a Java.NET project with public mailing lists. You can go and read the archives. Anybody can go and read the archives. And you can follow the expert group traffic if you would like to by joining the users list. We're currently in early draft review, which means this is the first formal exposition of the API that we're looking for feedback on after several months of work now. We'll be in Java EE7 next year, so we've got to get things straight before then. And we also have a reference implementation that Oracle is doing that will implement the specification, and that's being done at another separate Java.NET project called Tyrus. The Tyrus builds are now tracking the early draft version of this specification. So everything I talk about today is in the early draft, and then if you go after this and download the Tyrus code, that will implement not all of the features, but many of the features in the early draft. And also Tyrus is being bundled as of last week, I think, in the Glassfish 4 builds. The expert group, it's not always the case, but I think in this case we got all the people who are, nearly all the people who are implementing WebSockets as a Java API, which I think is really good. That's really important, so that's great. And here they all are. And anyway, so now let's get to the API. So this is where the bulk of the talk is, just to show you the API. Here's a high-level view. We've got API for the WebSocket events, for various different ways of sending messages backwards and forwards between a client and a server. We've got a notion of a session, which is really a sort of high-level view on the connection, which encapsulates the idea of a conversation. We haven't quite separated it well yet, but we will have a separation of client and server APIs. The idea here is to bundle the server APIs with EE, but also have a separable client API that we hope will be incorporated into the JDK at some future time. We have a bunch of annotations to try and make this easier for people in the EE style of turning POJOs into more interesting objects. We have an SPI for WebSocket extensions and data framing, and then we also have integration with the EE web container. We're trying to view this as just part of a bigger web application. So here's the tour of the APIs. So just a disclaimer here, this is early draft. We have several more drafts to go. Things like method naming, class naming, maybe even one or two of the smaller features might change as we go along. But this is our first outing of this API, and so that's what I'm going to show you. Things may change before we go final. So just some basic examples to start with. This is a server component that is extending. Hello server is my application class. Endpoint is one of the key classes in this API. This embodies the notion of one end of a WebSocket conversation. And in the API that we have, the idea is that your application subclasses endpoint and overrides one or many of the lifecycle methods that intercept events on the endpoint. And in this example, what we're doing in the overridden onOpen method, we are, in this method, we're going to get a callback from the container when a new connection is established. The session object that the container passes into your code, your application code, represents the connection with that client who's just connected into you. And then the first thing we do with the session is add a message handler. This is like adding a listener that's going to listen to any messages that are going to come in as part of this session or on this connection from the client. And here we add a variety of message handler. We've got lots of different types of message handler. Here we're adding a simple text handler, which has one method, onMessage, which simply takes a string parameter. and we're just printing out what the message was. And so in this case, what we're doing, we're adding the message handler so that anytime a text message comes in on this connection, we'll get the text message passed into our onMessage method, and then we can go and do whatever we want with it. So very simple. We're just listening to text messages from client here. So already, even in a simple example like that, we've covered some of the main classes here. Endpoint, this is the application class that or the API that you subclassed as the entry point for an application. And this intercepts events like onOpen, the open event, error events, close events. Then we have a separate notion of developer components that listen for messages, dedicated just to listening to WebSocket messages. And they're all different flavors of message handler. Then I didn't show, but I will in a moment, we have a notion of a remote endpoint, which from, if I'm a server, my perspective of a remote endpoint is it's the other end of the conversation. And that's the thing, the object reference that I get when I want to send a message back to my peer in this conversation. And then, as Ed mentioned, we have a notion of session, perhaps a little too broadly named, but session, which represents the active conversation between the two parties. So just to double-click into that a little bit more, what this looks like as an object model, my server, let's say my endpoint there is just that simple hello world application. My endpoint has a number of message handlers associated with it, 0 to n. You could listen to nothing, or you could listen to things in multiple form. Then for each client that's connecting into my server, there's one session, and each session holds on to one remote endpoint representing that client. So a relatively simple object model. Here the object model is showing two clients connecting to the same endpoint and having some kind of WebSocket conversation. So what does it look like? Oh, we just showed that. So here we are. This is there's that same code again. Now, what does it look like on the client side? Well, WebSockets is a protocol that's mostly symmetrical once the connection has been established. The handshake, as you saw, is not a symmetrical operation. So, but typically, clients, there tends to be one client tends to make one or a small number of connections to a server, and a server is managing to accommodate one up to millions of connections from millions of clients, maybe like on Facebook, for example, at 3 o'clock in the afternoon. So you can see that we're using the same API objects to represent the client's perspective of this connection, where the client who is connecting is also an endpoint because it's one of the ends of the conversation. It has message handlers too for when the server sends a message back to the client saying, there's a stock update or there's a new chat message. It sees a session object just the same way, and its remote endpoint represents now the server that it's connected to, instead of the other way around. So here's the client-side code. Again, our application hello client subclass is endpoint, and we're intercepting just the onOpen event, which indicates that there's a new connection has started with the server. And this time, instead of adding message handlers to listen for messages, the first thing we're going to do in this application is to send a message to the server we just connected to. So we get from the session object that's passed in as part of this event the remote endpoint, and then the remote endpoint contains a whole host of methods for sending WebSocket messages, and that's that. So sort of if you combine the two things together, you could produce an echo server. And you may know this already, but there's a website that you can test your browser, which has a little echo server on it. Not this one, but a different one. We'll just echo any WebSocket messages that you send to it. So here, just to go through it again, we're intercepting the open event. As soon as the connection is opened, we add a message handler to handle any incoming messages. And here we're just handling the text messages. And at the same time, as soon as we've configured our message handler, we're going to send a message back to the client that called us and just echo back the message that they sent. So configuration, we have a concept of configuration objects. We include a number of default configuration objects. We're trying to make the easy things easy. Let me go through the example first. In this case, the top half of the slide is showing the client configuration, the configuration process for a client endpoint. We make the URI. The top half shows the server side of it, where we create the URI where we're going to deploy the endpoint, where it's going to be registered. We get the server container. We get the server endpoint configuration, and we use just the API's default server configuration and pass it that URI, and we call to the server container to publish that URI. Now, the default matching algorithm, if you just use the API defaults, is just an exact match. All these algorithms are overridable in your applications if you want to have some star matching or regular expression matching or something even cleverer than that. You can override methods on the endpoint configuration or provide your own to have different algorithms. Then on the lower half of the slide, we're on the client side. We get hold of the client container, and we instantiate our application object, and we connect to the server using the default client configuration object. I'll go into a little bit more detail about that, but config's relatively easy. So client configuration, again, these are abstract classes that can be subclassed if you want to provide different ways of doing this. But what you can do by default is easily add in any sub-protocols or extensions your client application needs, any message encoders, which I'll talk about in a little while, that your client is going to use, and then the request URI it's going to connect to. On the server side, the configuration allows you to specify algorithms for the negotiation of sub-protocols and extensions, the message encoders and decoders on the server side, and some of the other aspects of the handshake, like whether you check the origin or not, the URI matching algorithm that you would like to use, and also to be able to examine the details of the handshake request and response if you want, for example, to add custom headers into that, as I know some people do. So we've kind of set up the basic, hello world, echoing, simple messages, text messages. One of the more interesting parts of the protocol is that it allows, a variety of different modes of sending and receiving messages. And we've tried to reflect a number of different styles based on, message style, message size, program style. So if you're listening for message, we have, I'd mentioned that you use a message handler, you configure those. We have a number of different kinds of message handler so that you can listen to incoming messages in a variety of different ways. So we already saw the simple text message handler, which is just an on-message callback. You can, the WebSocket protocol divides messages into either text-based or binary messages. So for incoming binary messages, there's an analogous binary message handler. So this is good for smaller messages where it's okay to process, a small message all at once and wait for the whole thing to arrive before you get the callback. For larger WebSocket messages, you may want to process things in more of a stream-based manner. So we have, for asynchronously processing incoming messages a piece at a time, we have the async text message handler. which is a relatively common pattern in the different implementations of WebSockets that we leveraged, or I suppose copied. Where each fragment that comes in, you get a callback for each fragment, and then the final fragment, the Boolean that you can see here on the right-hand side on the onMessage call, is set to true, and then you know that the complete message has arrived. And then there's the analogous binary form of that. You get a partial byte buffer coming in, and then when you get the last part of the message, you get the last byte buffer. The Boolean is set to true. Then, I suppose people are a little bit divided whether they still like to use I/O or whether they, need the scalability of true asynchronous processing. But there are lots of libraries that support traditional blocking I/O. So we've also provided, as you can see here, the I/O stream versions of processing messages as a reader in the 5th line, and as an input stream. So if that's the way you like to process messages by using a blocking stream, then you can add that kind of message handler. And then finally, I mentioned encoding and decoding. One of the interesting aspects of WebSockets is being able to take developer level objects like a chat message or a drawing message, as I'll show a little bit later, and provide decoders and encoders that can translate those developer level objects to and from strings and binary messages. So when you provide encoders and decoders, which I will show how to, you can also opt to receive messages in the form of a custom developer object, provided you provide the correct encoder for it. All these APIs are single abstract method entities, so they're Lambda ready, so that when we can switch to JDK7, then you'll be able to, when we can switch to JDK8, you can write these message handlers as Lambdas if you want to. So let's look at just some of those different modes of processing an incoming WebSocket message. We already really covered this one. It's just there for completeness. This is handling on message just as a simple string. So if you want to, this one is handling text in fragments. At each piece of text as it arrives, you can get a callback for each piece of text. So here, when we add the message handler, we add the different variety of message handler, the async text handler, and its method signature, its single method is on message part, and this receives the callback with partial strings sequentially in order until the last one arrives when the Boolean flag. I'm going to do questions at the end just in case I happen to stumble on the answer in a later slide. And then you can construct the message in the order that you received it. Then here's the streaming version. So it's a member class of message handler, member interface of message handler, the character stream, with its on message that takes the reader. And then you can use the traditional reader APIs to read things as quick as, as small chunks or as big chunks as you like. And you will just have to wait till the chunks arrive. And then I'd mentioned that you can opt to receive messages in the form of developer objects of your choice. Here, my custom message receive application wants to receive custom message objects, which is some, developer object that I created. And here we use the decoded object flavor of message handler. And you see the signature is the custom message that I want to receive. But this is dependent, to get the callback here, on me having provided a custom message decoder, which you see on the lower half of the slide, which implements the text decoder interface. And its contract is simply to be able to decode a string into that developer level object. So this is a very straightforward, simple approach to being able to elevate WebSocket messaging from strings and binary arrays up to something a bit more friendly to developers. Now, on the other hand, sending messages, we have really analogous modes for sending messages as well. The top two show on the remote endpoint interface that I mentioned earlier. This is the representation of the other end of the conversation. We have this variety of methods for sending messages. The top two are the simplest. If you have a smaller message, small chat messages, things that are relatively quick to transmit. We have send string, and I apologize, the binary version should say send data, I believe. Then again, you can send things in fragments here in the third and fourth lines by sending things in chunks. You can also send things using blocking I/O, using writers and output streams. And then analogous to processing messages, you can send things in the form of a custom developer object, provided you provide an encoder so that the container knows how to turn that custom developer object into either a string, WebSocket message, or binary data. And then the ones that I've starred here, the modes that I've starred, also have additional flavors where you can send them by completion or by future. And so if you send by completion, what this means is that the send call returns immediately. You additionally pass in a send handler, which gets a callback when the container has fully sent the message. It doesn't provide a guarantee that the message was received and processed by your client. But if you're sending, messages to hundreds of clients, you can hand off that work to the container while your program thread can carry on and do something else in the meantime. So here we are, some examples of these different modes of sending now. Basic send, we saw this one before. We get the remote endpoint, and we just called send string and send the whole thing all at once. And this method blocks until the container has fully sent that message on the connection. Here's the blocking streaming send version of it. Again, we just get the remote endpoint, and this time we are going to send a text message through the writer interface. So we just call writer.write and send things that way. And again, this is a blocking process, but at least we're streaming things now. And then you can send things now either by completion or by future. So here is an example of sending a message by completion, where the relevant method is send string by completion, as well as the message, hello in this case. You send in a send handler, which receives a callback either when the message has been properly sent, or if there's some error, it receives an error. So as you can see here, in our send handler, we can, when we get the callback, we can check whether the message actually was sent by the container or whether some error occurred on the transmission. And then this is the other version of sending that message by future. So now, again, the send message here, send string by future, returns immediately, probably before the message is actually sent. And you're given a handle to a future object, which you can wait around for, you can interrogate for completion and so on your own thread. You get the send result, which gives you any exceptions that are raised during the send, if any. Otherwise, it tells you it's okay. So that's different varieties of messaging, which hopefully will accommodate a wide range of messaging style applications, from smaller messages to big scalable chunks of data being sent backwards and forwards. Now we're going to talk about POJOs as WebSockets. So this is very much in the EE6, EE5, and EE6 style of things, trying to take what for some people is a complicated API and using annotations to help making easy cases super easy to write. So back to our Hello World server example, we saw this earlier. All we're doing is listening in for a text message. The annotation version is this one. It's the hello bean. And now instead of implementing subclassing, implementing endpoint, and using API classes to decide in what form to receive messages. We use annotations instead. So hello bean is a POJO. It doesn't implement anything in particular. It could be some pre-existing class that you already have. It's decorated with this at WebSocket endpoint annotation, which in this case has hello as a path. So this tells the container that the developer would like this POJO to be deployed as a WebSocket endpoint under the URL hello on the server. And then its handle message method, note the different method name from onMessage was the API version, is decorated with the at WebSocket message annotation. And this tells the container that this is the method on this POJO that the developer would like to be called back every time a message comes into this endpoint. And again, we've opted for the simple string form of handling that message. So you can see for, especially for new developers, for developers who like annotations a lot, for development tools that like to set up templates for things, this makes it a little bit easier. Let's see. Oh, yes. Then this example, back to our Echo World server, which not only processes the incoming message but bounces it back to the client that sent it. I wanted to show you that version in the annotation. So this time, again, we're just using the WebSocket endpoint class level annotation to say this POJO is a WebSocket endpoint. And we're decorating the echo method with the WebSocket message annotation. And the WebSocket message annotation allows for a return type from the method. And if there is one, and in the correct format, it will treat this as a message to immediately send back to the client. So this is a somewhat useful case for developers to make easy. So looking a little bit more deeply, we have a number of other annotations for doing this style of POJO programming, turning POJOs into WebSocket endpoints. I talked about the WebSocket endpoint class level annotation. That's the first one that people would learn. Then you can intercept some of the lifecycle events, WebSocket open, and the close event, WebSocket close. And you can also decorate one of your methods or several of your methods with error handling code using the at WebSocket error method. Very recently in the specification, we've added the ability with annotations not just to provide a URL to deploy the endpoint to, but a URL template. This has become quite widely used in a style of web programming. And in order to be able to intercept those parameters of the URL template, we have a method parameter level annotation called WebSocket path parameter that allows you to receive a matched segment of a URI template. And then, of course, WebSocket message is kind of the workhorse, which tells the container, these are the methods, or this is the method that I want to process incoming messages. So all of these annotations, most of them come with various different attributes that allow you to twiddle the dials and knobs of the annotations. The WebSocket endpoint annotation allows you to provide the path where the endpoint is deployed to. And here we've got an example, hello, or a very simple URI template. Allows you to list out the method, the object decode, message decoders, and encoders that you want to use for your POJO, and also the subprotocols that your POJO supports for WebSockets. And then WebSocket message, the annotation, allows a relatively flexible class of method signatures to be decorated with that WebSocket message annotation. Any method that has a parameter of string, byte, or any Java type for which there's a configured decoder, an optional session parameter, because you usually typically want to know who the message has come from. 0 to n string parameters for if you're using the URI template style of deployment matching. And then a return type of string, byte array, and any type for which there's an encoder. So I think, I haven't really talked about this with the expert group, I think we should probably add Java primitive types, collections of those things to that list. Obviously, I will talk about that in the expert group before adding it, but I think that would be a good idea to add to this list before we go final. Oh, now I have a little demo. No presentation is complete without a demo. So I wanted to just show an example of something running. This is running on Tyrus. And it's one of those group drawing applications where, two people are drawing a picture and they've got a kind of joint whiteboard. So just give me a second to get it set up. So here's my little drawing canvas. And this is in Firefox on Mac, obviously. So these are two separate browser clients. So as far as the server is concerned, these are two different clients. So what's happening is every time I draw on either client canvas, the client canvas is sending through the JavaScript API a little WebSocket message telling the server endpoint what it just drew. So it's just drawn some red circles. Let's do, I don't know, small square. And then when the server gets the message, it's bouncing out to all the other connected clients that it has connections with from this drawing application, just exactly what got drawn on one of the other canvases. So the idea is that when everyone's connected at the same time, if anyone draws on the tool through mediation through the server, everybody gets the message about what just got drawn and everyone ends up with the same picture, except when you clear it. But so that's just a very simple application of this kind of technology. So then really the idea of showing you that was so that I could jump to the slide, which I think ties a lot of these concepts together. And I'm showing you here the server-side endpoint of that demo application. So this is the Pojo, the group draw server that is being run in that application. Every time one of the clients draws a message, this group draw server, Pojo, receives an object called a drawing message. And this is a simple object in this demo's case, which has, whether it's a square or a circle or something else, the color and the size of it. So you can see it's not just a string or a binary data, it's actually a Java object with methods to indicate the shape and the size and the color and so on. And in order that the Pojo catches those messages, what I do is I declare this as a WebSocket WebSocket endpoint at the top. I give it a URL, the draw URL, which is where the endpoint gets deployed to. I need an encoder and a decoder to translate the incoming WebSocket message, which is a string, up into a drawing message object. And then when I send the message back, I need to be able to translate the outgoing message from a drawing message object back down into a string. So that's what the WebSocket endpoint annotation is doing at the top. And then my shape created method is annotated with @WebSocket message. So I'm telling the container, this is the method that wants to handle any drawing messages coming from my client. Then in my implementation of that message, I get the message as well as the session. I get hold of the server container that I'm in. This is a WebSocket API. Then I can list out the active sessions, the current connections to that server. And then I can iterate through them. I throw away the client that sent me the message because he doesn't need to get the same update of the thing he just drew. And I send all the others that exact same drawing message back out again so that they get, whether I drew a red square or a blue circle. So you can see this, I think, exercises many of the aspects of the API and the annotations that I was talking about, the different styles of messaging. Here In fact, we are sending those objects asynchronously. You can see we're calling send object and passing in a completion handler. So this means if I have 100 clients all using simultaneously this drawing tool, these send object calls in this iterator, they'll return immediately. So I can get on with something else in my application. Meanwhile, my send handlers get the callback when the message is sent by the container. So we showed the different modes of operation. We showed encoding and decoding. We didn't show URI templating, but I think we showed pretty much everything else. So let me just do a time check. Oh, I didn't have time for questions. Packaging, this is an area that may develop a little, but the basic idea here is on the client side for the client API that we hope will be incorporated at some future time in the JDK. Applications will just simply package their application classes and any resources that they use into a jar file, and then they use the class path to indicate where the WebSocket API implementation is, or not, if it's already included in the underlying platform. And then in the web container for Java EE, the idea is simply to package these classes in the WAR file, either in the webinf classes or in the webinf lib directory, packaged as a jar file, and any resources. So we're just piggybacking on existing packaging models here. Some features I didn't talk about, like I say, this is the first time we've really talked about this, so I didn't want to jump ahead to some of the things we added later. But just so that you know, I'm not going to talk about these in details, but just so you know that these are features that are part of this API and this specification. There's, WebSocket, the protocol is by design extensible, and that has a formal way in which people can create extensions of the protocol. Multiplexing is one that's been worked on already. Compression is another one where WebSocket message is compressed. This obviously takes both ends of the conversation to agree on that's how they're going to play the WebSocket game. So we're going to allow Java developers also to be able to implement these extensions by providing a data frame and WebSocket extension SPI. It's kind of an advanced feature. Most developers won't need to do this. They may even borrow someone's extension that someone else has created. Maybe we'll even provide one or two in our reference implementation. I touched on it, and we're really sort of trialing more complicated schemes for URI matching. Exact match of URIs on endpoints gets you so far. But it can be very useful to essentially parameterize the URL that you publish an endpoint on and allow your clients to connect with a multitude of URLs to that endpoint, each with a different state indicated in the URI template. So we've included that in early draft review. For those of you who know about URI templates, it's URI templates level 1, which is the simplest form. Especially interested in feedback on that. And we also include, the definition of how WebSockets integrates with the wider web container and other EE services. So being able to inject things like the HTTP session of the web application you're in into a WebSocket application. If you imagine even something like the news feed on Facebook, where you have scrolling, Mary had a cup of coffee or whatever people seem to say on Facebook these days, is scrolling away, but this is all part of, which is probably something like a WebSocket application, or if it's not, it should be. Bundled together with a larger web application that is the news feed. There's clearly a state that you would like to share between individual WebSockets on a web page and the web page itself. And also integration with the web security model, how we apply the web.xml and security constraints in the web layer to WebSocket endpoints, so that you can say, I'd like this WebSocket to only be accessed by people who are authenticated and people who are authenticated and belong to certain roles within the deployment environment. So these, I've built them as advanced features. They're probably not. It's just that I wanted to cover the basics, as this is the first time we've talked about this JSR. So I'll leave you, I think, with about 10 minutes for questions. And just to say, there's a bunch of people already starting to implement this. Is Greg here? Jetty, I know, is looking at implementing this. We've got Tyrus is quickly catching up with the expert draft. Go download it if you want to, try this stuff out. That draw sample is in Tyrus, for example. Okay, so with that, questions. I think you go first.
Is there any support for secure transmission of WebSockets?
Yeah, so on the client side, just by specifying the WSSL URI, and then on the server side, the mapping is how to apply the security constraints in the web XML to protect resources. You're using the same URI scheme. So the idea is just as if you're protecting a servlet map to foo, we would like you to be able to protect a WebSocket endpoint map to foo using the same mechanism, essentially. And the protection level is at the opening handshake, which makes it particularly easy because that's an HTTP interaction already. So it's kind of a natural fit. Yes?
Do we need to open up any more ports on the firewall?
Well, it depends on the implementation. I'm not sure how much we'll specify a separate port for that. I mean, some people are just using 880 for this, and some people are using a dedicated one. So we haven't really talked about that in the expert group, so I'm not sure how much we're going to need to define that. So this is like a bad way of saying I don't know. We don't specify anything yet. I think some people do and some people don't today. You had a question in the corner.
Yeah. Is there a way using the annotations to handle the different message types, like the asynchronous messages or the chunk messages?
Well, in the current draft there isn't. You just get the whole thing, so string or binary data or developer object. But I think it would be a good idea to be able to get things in chunks. We'll just have to, which would mean adding some attributes to the WebSocket message annotation, and then specifying how the container interprets the signature. I'm not saying we definitely need to think about it and design it carefully. I think on the face of it, it's a good idea, but it's not in the current draft.
And there was one follow-up to the annotations, which was, do you guys plan on implementing similar to what the JAX-RS spec does, where the endpoint is set at the class level, and then at a particular method level, you could specify an additional path piece or
we looked at
it.
We look to JAX-RS for sort of inspiration, but the model doesn't quite carry over. In JAX-RS, you can essentially allow a method to be an endpoint using sub-resources. It doesn't quite fit this model because there's more life cycle. So we've opted, as you can see, for something a bit coarser where the endpoint is a class. It makes it a bit, we sketched out a few things doing kind of sub-resources and sub-paths, but then where the, on open and on error and on close methods, the lifecycle methods, it starts getting a bit tangled up, to be honest, because you're doing kind of 4 different things. With JAX-RS, you're really just doing one. It's just like, give me this, give me this, give me this. WebSockets is a more complicated protocol, so we might talk about it more, but it didn't map so well. That part of JAX-RS, the analogous, didn't map so well. Let's do here, yes.
Can you show us the client side, the client endpoint, and how you handle the input from the application you showed us? How you handle the input?
Oh, the JavaScript code?
Oh, so it's JavaScript.
Yeah, of the draw application.
Is the example available?
Yeah, it's part of Tyrus, the reference implementation. There's a chat one.
Okay, so
Here it is.
there is JavaScript and
Yeah, it's JavaScript. This is showing just the JavaScript client. The server was written in Java, showing the API. In this case, primarily, for a while, it's going to be the clients are going to be mostly JavaScript snippets in web pages. We're providing a Java client-side thing for rich clients doing WebSockets, but most people doing WebSockets are doing JavaScript clients at the moment. So here it is. Let's see, WebSocket. This is a API class from JavaScript from that W3C standard. Create a new WebSocket, and then it has its own way of intercepting events and so on. It's pretty straightforward. You had a question.
Is there going to be any baked-in concept of a channel or a room or a topic like that? Or if not, is there going to be a way to store some type of metadata on a session to distinguish them?
When we were experimenting before the JSR, we had sort of simple property stuff. Something that I'd like to do is to look at dependency injection for allowing people to store things in some sensible place, probably on the session. There's when you're in the web container, there's a lot of different places to put this information already. So we have to be careful about providing sort of more storage on our API when you could put it in a HTTP session and an EJB somewhere. I mean, there's lots of places, but one of the things we'll look at. You had a question here at the end.
This may be outside your purview, but all of the containers you mentioned were basically having HTTP go directly to a servlet engine. What about those who need Apache or IIS in front and AJP? Is that world catching up to this notion?
You like having a gateway in front of the web server?
Having an Apache web server, the native Apache web server in front of Tomcat.
Yes.
Is that world catching up with the Tomcat connectors and Apache to WebSockets, or is this kind of...
I don't know. I don't know, to be honest. So we'll keep that one quick. My boss has a question.
OTV supports the cryptographic connector as a channel that could actually go into the server and then the WebSocket would be shared.
Okay. There we are. The green shoots are growing. You had a question. Yes.
You're opening up a two-way connection across multiple clients. Could
Yeah.
you talk about some of the challenges around resource sharing and locking? Could you run into a situation where you have two people drawing at once, some sort of things like that?
Well, let me try and find a slide that maybe, hold on, that frames it a little bit. Yeah, I mean, I think as much as we'll specify is what the threading, what we need to specify, and we've done to some extent, is if you're an endpoint developer on the server, what expectations you have of container threads calling your code. And so, one of them is that in asynchronous messaging, the calls should be sequential and no two threads calling with, here's one bit, here's one bit, here's one bit, either in the wrong order or simultaneously. We'd like, I think, to have multiple calls from the same client arrive sequentially at the endpoint. So the endpoint, if it just focuses on one client, it's only getting sequential calls from that client. Even when it has 100 clients, it might have 100 threads coming in. It wouldn't be 101. Each client would have a dedicated, but not more than one thread at any time calling into code. There are a number of those concurrency situations that we've made a start on clarifying for the developer, because I think our goal is to provide a relatively friendly development environment while sort of delegating the issues of scalability into the implementation. So
That's just like a fun concept for me to think about and read on. Are there any resources you can point me to?
I would look at the Kazing WebSocket gateway, because I'm sure they've solved these problems. They've got a WebSocket gateway in deployment. So, I could say more nice things, but if I wanted to know the real answer that you're asking, I'd look there, I think. You had a question. Oh, and Netty as well, yeah, of course. Yeah, Netty.
So if I present different types of messages, do I have to create multiple endpoints, and will that open up a lot of sockets between the same client and the server?
No. If you want to send, a binary message, a string message, an asynchronous message, and then an apple, you just have one endpoint connecting to one remote object, just one connection. The session and the remote endpoint are one-on-one with the underlying connection, basically, unless the underlying implementation is using something like multiplexing, where it may choose to piggyback the work of several connections into one physical connection.
You have a drawing message object that endpoint, you find a different object on the same endpoint. How does it know which message is coming in?
I'll talk to you in a minute, if I can. Thank you, everyone. Enjoy the rest of the show.